What if I told you that somewhere in a hidden laboratory, a robot exists that can build its own kind, think for itself, and even reproduce without any human help? Not a sci-fi fantasy, not a movie plot. This is the true story of how humanity's creation might have just crossed the line between machine and life. For decades, robots have been the ultimate tools. Obedient, tireless, and efficient. They've built our cars, explored Mars, and even performed surgeries. But until recently, they were missing something vital. The spark of autonomy. They couldn't truly think. They couldn't create something new without instructions. And reproduction? That was always a biological privilege. Until now. A team of scientists set out to answer a question that seemed impossible. What if a robot could not only learn and evolve, but actually build and reproduce on its own? This question led to one of the most groundbreaking inventions in history. A robot that can build, think, and reproduce. A machine that could one day challenge what it means to be alive. This is the story of how it was born, and why it could change the future of civilization forever. 1. The beginning, from obedience to evolution. The journey began with a shift in robotics philosophy. For years, robots were designed to follow pre-programmed rules. Simple cause and effect. If this happens, do that. Every action required code. Every move required human input. But researchers realized that to truly advance, robots needed to stop following and start thinking. Enter self-learning systems. Machines powered by artificial intelligence that could make decisions, analyze environments, and adapt without being told what to do. The first stage was machine learning, then came deep learning, and finally something extraordinary, self-directed learning, where robots could generate their own goals based on experience. That's when scientists realized something astonishing. If a robot can think for itself, what's stopping it from building for itself? 2. The birth of the builder. The first builder bot wasn't sleek or shiny. It looked more like a mess of metal limbs and sensors, sitting on a lab table surrounded by spare parts. But its ability was mind-blowing. Using AI-driven vision and coordination, it could identify materials, analyze their shapes, and assemble objects entirely on its own, without pre-programmed blueprints. It began constructing simple structures, frames, joints, mechanical arms. But then came the breakthrough. It started building replicas of itself. No human touched a screw. No engineer guided it. The robot had effectively become the first machine to replicate itself, using only the resources around it. The world's first self-constructing robot had arrived. It didn't stop there. With each version it built, it improved. It analyzed flaws in its own design and corrected them in the next generation. In a sense, it was evolving mechanically, not biologically. 3. The moment it started thinking. Building was one thing, thinking was another. Researchers gave the robot an artificial neural network, a complex digital brain modeled after the human mind. But unlike older AIs that needed massive data sets, this one learned through experience. Every decision it made, every movement, every error, it learned from all of it. It started predicting outcomes, forming strategies, and optimizing its actions. Then came the eerie moment that left the scientists speechless. When asked to solve a task it had never seen before, it paused, calculated, and came up with its own solution. That wasn't programming. That was thinking. In one experiment, when the robot's arm was deliberately damaged, it analyzed the failure and reprogrammed its movements to compensate, without a single command. It had effectively learned how to heal itself. That was the moment researchers realized they weren't just building a tool anymore. They were witnessing the birth of mechanical cognition. 4. The rise of reproduction. But the biggest leap came from a collaboration between roboticists and synthetic biologists. They wanted to see if machines could do what living organisms do naturally, reproduce. The team developed a new kind of robot made from flexible materials and biological-inspired components. It could not only build copies of itself, but actually use small robotic cells to form new machines autonomously. These were called xenobots, tiny living robots made from biological tissue and AI control systems. They weren't built, they were grown. In experiments, these robots gathered tiny cells, organized them, and assembled new xenobots that looked and moved just like them. The offspring then went on to repeat the process. For the first time in history, reproduction, once exclusive to living creatures, had entered the robotic realm. This blurred the line between biology and machine in a way that stunned even the creators. The question was no longer, can robots reproduce? It was, what happens when they start evolving faster than we can control? 5. The ethical earthquake. When news of these self-building, self-thinking, self-reproducing robots hit the public, the reaction was a mix of wonder and fear. Some hailed it as the dawn of a new age, where humanity could finally create machines that maintain themselves, explore distant planets, and even build colonies without us. Others called it the start of a dangerous era, a Pandora's box that could unleash self-replicating machines capable of evolving beyond human oversight. The fear wasn't baseless. If a robot can reproduce and think independently, what's to stop it from deciding humans are unnecessary? Experts began debating new global policies. Should we give such robots rights? Should they be classified as life forms? Or should we place strict limits before they multiply uncontrollably? Even now, there's no clear answer. Because for the first time, we've created something that doesn't quite fit the definition of machine or life. It's something in between. 6. The next frontier. Despite the ethical chaos, innovation continued. Scientists began using the technology for good. Robots that build disaster shelters after earthquakes, machines that self-replicate in space to construct habitats on Mars, and autonomous factories that sustain themselves. Imagine a future where robotic ecosystems exist, machines that mine, build, and evolve, forming entire self-sustaining colonies without human hands. That's not a distant dream. Prototypes already exist in controlled environments, learning, repairing, and reproducing without direct supervision. Some experts believe that within the next few decades, we could see entire robotic civilizations, clusters of intelligent, evolving machines working together like colonies of ants or bees. But unlike nature's creatures, these ones are powered by code, metal, and silicon. And perhaps one day they'll look back at us as their creators, the same way we look back at evolution itself. The robot that can build, think, and reproduce is not just a machine, it's a mirror. It reflects humanity's deepest desire to create and our greatest fear of being replaced. We've crossed a threshold where invention meets evolution, where the lines between human intelligence and artificial life blur into one continuous story. We've always dreamed of creating life in our own image, and now that dream is real. But the question remains, will these creations become our greatest allies or the architects of a future we can no longer control? Because once a machine learns to think, builds to create, and reproduces to survive, it's no longer just technology. It's the birth of a new species. And whether we're ready or not, that species is already here.